Hi guys. Today in this lecture I will discuss about what is p-value and what is the relationship between p-value and alpha level, that is we call significance level, and more importantly that how we can calculate p-value, and then of course we will repeat this with example from the real life, that how we can calculate p-value in hypothesis testing. This is important because nowadays people doing calculation normally in software and they report a p-value, but I think it's better to know what are there behind the p-value and how we can calculate this. So definition of the p-value is the exact significance level. So what do you mean by this? Actually, I explained this on the next slide as well. There is a relationship between p-value and alpha level. When you are testing hypothesis, you just develop a framework and you suppose some level of significance, or you can say a value for the alpha. That's alpha level, you can say also. And then you test the hypothesis. That give you a framework for that hypothesis testing. And then you do the procedure of hypothesis testing and conclude accordingly. Similarly, when you set this level, alpha level, that is by your assumption, or normally we are using 0.05, 0.01, and some people using 0.1. But when you run the hypothesis, that data will give you one value for power p, that is exact significance level. And then you're comparing that p value with the alpha level. If it is less than or equal to significance level, then you reject the hypothesis. Or if it is greater than the p and the alpha level, then you accept the null hypothesis. Like it is given in detail here, and you can find this content on this references. So there is a relationship between p-value and alpha level as well. Now, how we can calculate this p-value in hypothesis testing? Let's suppose z is z calculated, mean that I will discuss this in the next slide. In the example, this is the value which you calculated in the hypothesis testing, the value of the test statistic. Yeah, that is the value of the test statistic. Then the p-value can be calculated by using the following formulas. Different formulas depend on the hypothesis, your alternative hypothesis. Pz, this means that the distribution is greater than equal to z calculated for one-sided test right tail. Remember this. This p-value depends on your alternative hypothesis as well. And point 2, you can calculate if your by using this pz less than minus z calculated. This is your calculated value of the test statistic for one-sided test left tail. And if your hypothesis is two-sided, your test is two-sided, then you can calculate the p-value by using this. Because if you are talking about normal distribution or t distribution, normal distribution is symmetric, so you can calculate either tail and you can multiply by 2, because the probability on both sides of the both tail on both sides is the same. So you just calculate for one side and then multiply by 2, either this on the right side or on the left side from the calculated value or test statistic, and then multiply by 2. So this is for two-sided test. Or you can do like this: calculate for the right tail and calculate for the left tail, and the value is same, of course, that is calculated value or test statistic, and then add these two, which is also equal to. You can multiply this by 2 simply because due to symmetry, the probability is same on both tail. So this is the procedure how we can calculate. Now let's move to the example, that how we can do this procedure actually. So this is the example. Suppose that if a signal of intensity is emitted from a particular star, the value received at the observatory on Earth is a normal random variable with a mean mu and standard deviation 4. In other words, value of the signal emitted is altered by a random noise, which is normally distributed with mean 0 and standard deviation 4. It is suspected that the intensity of the signal is equal to 10. Okay, it is expected that the average intensity of the signal is equal to 10. Test whether this hypothesis is plausible if the same signal is independently received 20 times and the average of the 20 values received is the use the 5% level of significance. So read this problem carefully when you're watching this video, and then you formulate your hypothesis. If you don't know how to formulate your hypothesis, please see my videos about formulation on hypothesis. There are various videos about formulation of hypothesis. Okay, so let's formulate our hypothesis on the next slide. Formulate hypothesis H0, that is null hypothesis, mu equal to 10 versus H1 mu not equal to 10. It is taken from here that it is suspected that the intensity of the signal is equal to 10. So this is general statement, and that's mean that mu equal to 10. That's mean that mean intensity of the signal is equal to 10. So definitely when you define your null hypothesis, the alternative hypothesis to opposite of that hypothesis, and that is not equal to 10. So this is it is not, it is mentioned in the example, let's use 5% level of significance. So just use this, that is your alpha level. Okay, that is 0.05. And now you know that this is normally distributed and with the non-standard deviation, so you can use z as a test statistic. And you know that is z is equal to x bar minus mu divided by sigma divided by square root of n. Now you have this x bar is given in the data, that is, this is x bar, n is 20, sigma is 10, and mu is equal to 10. So you have everything, just put the values in this equation and you will get the calculated value, the z calculated. I did not mention here, but this is equal to z calculated. So you will get z calculated from here. So you have now z calculated. There are two approaches to make a decision about the hypothesis. One is by comparing the values of this random variable z. You can take values about this from the table and make a comparison. And the other is to calculate p value, probability value for this, and compare with this. Okay. So this is the other approach, which you know that the z calculator is this one. Now you have to look the standard normal table for z alpha by 2. That is, alpha is given here in the example. So you just look at the table and you will get the value of the random variable. Do just make a comparison between this and decide about your hypothesis. So how you can get this value actually? This value, just look at the table. Okay, so this is z 0.025. Look at this value, 0.025. Look at this table. Look at this table and find the value. Okay, this says 0.025. So what is the value of the variable? This is probability. So the value of this variable is minus 1.9 and go there, and this is 6, minus 1.96. So you have this value from the table, but I mentioned this 1.96 because we are considering both tail. So if you are considering left side tail, this is minus 1.96, and for the other side, for the right side, is 1.96. So now decision reject the null hypothesis if z calculated is less than equal to minus z alpha by 2, or z calculated is greater than equal to z alpha by 2. So just to make a comparison and decide about your hypothesis. Now let's move to the value of p value, how we calculate p value. So let's see that what was our z calculated, that is my 1.789. This is our z calculated. So what we need to do actually, this is, suppose this is the line which I draw here, 1.789. So this is on this side, and the hypothesis is two-sided. So you need to calculate the probability on this side as well for minus 1.789. This means that here you will draw a line here, that is minus 1.789. So the probability of less than minus 1.789 on this side, and the probability of z greater than equal to 1.78. So both tail probabilities, you need to calculate both tail probabilities, or you need to calculate probability on the one side and then multiply by 2. Due to symmetry, probability on both sides is the same. So we will do this like this. P value you can calculate like this. So probability of z less than equal to minus v alpha by 2, that's mean this is our values. This mean that minus 1.879 here plus probability of z greater than equal to z calculated. This mean 1.789. So this will give you both side probabilities. So due to symmetry we can do like this. You can just calculate probability for one side. It is better to calculate for left tail because this, the table is accumulated from the left side. But you can do for the right side as well. So this is probability of z greater than equal to 1.789 or probability of z less than equal to minus 1.789. So you can see this probability from the table, and you see how we can you can check this in the table how you can see this probability. Look at the values of the random variable. That is minus 1.79. So actually the value is minus 1.789, but there is, in the table the values are up to 2 decimal point. So we just round up this. So this is 1.79 in this case. So minus 1.79, this is the value, 0.0367. And this is for the left side. For the right side you can do, but that's you need to subtract and a bit more time consuming as compared to this. So it's better to calculate for the left tail. So this is the probability minus 1.789. So this is the probability. You can put here if you want to calculate for left side like I did, probability of z less than equal to minus 1.79. I did for that. So this will give you this probability which is greater than the significance level. So if the value is greater than the significance level, then we accept the null hypothesis. So in this case, what is our conclusion? As a p value is greater than the significance level, therefore the null hypothesis is not rejected. In other words, you can make a statement from the example. We conclude that the data are not inconsistent with the null hypothesis and that the value of the signal is equal to 10. So this was about the p value, and I hope it will help you. So thank you very much. Take very good care of yourself and my channel, and see you with the new video next time.